Hi, my name is JANOS. I am the chief architect of the Simatic HMI panels by Siemens. For roughly 17 years now, I have been working with HMIs, but at least in the field of industrial automation, pretty much everywhere from the shop floor to the top floor. And today I am here to share our journey of continuous improvements and optimizations of the Qt framework with our panels. And what you can see now is a typical example of a factory. The picture was taken in one of our own factories, showing the automation. And real-time monitoring, intervention, adjustments on the production, or optimization of parameters, even just changing what you will produce next. All that you can do using HMIs today. Today, and I believe even the next few years, you will still need a specific location where a physical specific location where you can interact with the systems. You can handle alerts, alarms, see information live. And just to bring one example from one of my colleagues, the HMI panels are pretty much like light switches. If you wake up in the middle of the night, you don't really want to look for your smartphone or other device, try to authenticate, face authenticate in the dark, or use your sweaty finger to somehow unlock the device just to turn on the light. No, you want to hit the button right next to your bed and turn the lights on. And this is exactly what we bring for the industry with our HMI panels. Our products are used all across industries. If it's a 3D printer, a standalone machine, or a fully connected automotive factory, you will find our devices there. And the value that we bring is independent of the industry, independent of the use case. The visualization system that we built is flexible. It's highly flexible, allowing those panels to be used even in microbreweries, traffic control systems, everywhere. And it's a fit for any kind of automation. It seamlessly integrates with any kind of system you can imagine. And pretty much this is the picture again. I let you take a second look. I highlighted the HMI panels, I guess some of the HMI panels. I was not even able to capture all of them. Today, if you need your maintenance personnel, the operators, process technician, to interpret any kind of data, to interact with the system, you design an HMI panel in the system. And this is exactly what you can see here. So, moving on, it doesn't matter which level of the factory we talk about. Those interactions can be pretty much with the actors on the shop floor having a small e-ink display, displaying really just a few lines of information, to the PLCs having that small display on the front showing some relevant information, or the HMI panels providing the full and complete interaction possibilities, the end-on boards hanging from the ceiling showing production KPIs, helping the operators and the workers in the factory to perform, or even the planning department taking a look at the live production data from the offices or even from home. You can use our systems. And we already have a long journey behind us from the operator panels of the 80s, having just one line of text displayed, to the full HD multi-touch devices that we have now. And I believe that the future is even more interesting and bright in this field, going into the direction of customized and personalized content. So as you can see, we offer a solution no matter which level of the automation. And obviously this is a high variety on use cases and scenarios. And this is exactly where companies like Siemens play a key role. We standardize. We provide a consistent usability across all those devices, platforms, and environments. And to achieve that, we have to do a lot. We use JavaScript interacting with our WinCC unified object model to customize specific workflows and actions. We offer standardization with efficient workflows, libraries, flexible faceplates. We provide ready-to-use solutions for the typical use cases like parameter control, auditing, reporting, all that kind of interaction with the machines. We can even generate those projects from PLC program or database. And this level of variety, obviously, we cannot cover with just one product or with one product family. So therefore, as you can see, we have the view of things for the smaller devices, for the PLCs, not really having a big display. We have our unified basic panels for the price-sensitive segments. We have our comfort panels, the flagship devices with a stylish look, with a huge flexibility over the functionality. And of course, also the PC-based solutions, serving hundreds of remote clients and hosting edge load. So this is our rough system architecture. As you can see, this is a combination of multiple functionalities. But one thing is key by us, consistency. We built this common and modular platform in order to reuse as much as possible and to provide a consistent look and feel and experience for our customers. The hardware is obviously different, so we have different specifications, we have different screen sizes, but starting from the operating system, we have everywhere the same components. Our devices are embedded devices. That means there is no direct access to the system level. There is no chance to install any applications. It's a closed system. And to change all the settings to adopt your product, we have a control panel. It's in the middle, and this is actually the first place where you can find Qt in our products. This is a small application providing interface to change the IP address, to change all the parameters of the device. We also have an edge runtime on the devices. It's an industrial-grade hosting environment where custom workloads can be executed, also interacting with the system, also interacting with the runtime. We have also third-party applications like a video player, a web browser, allowing the operators to watch a tutorial, to read a document, and so on. But the real heart of our product, the most important thing on this device, is the HMI runtime. This is the guy taking care of the process backbone, communicating with all the devices on the shop floor, doing data logging, alarm handling, all kind of operations, and also rendering the wide range of projects and configurations our customers can engineer using TIA Portal. And this is where we decided long ago to go with the Qt framework and rely on the Qt framework. I think with this audience, I don't really have to explain why in an embedded environment with limited resources, where industrial-grade quality, robustness, and stability key, why we chosen Qt. So moving on, how do we achieve the consistency? What are the steps towards? The first step is the Qt library itself. We have custom-built Qt libraries with our own patches, making sure that all our requirements are fulfilled. We have one central team delivering those binaries, delivering those packages to the rest of the organization. We have a separate data model also for the remote communication, for the data, the process backbone. And then screen models. Those screen models are pretty much views in this data, views in this runtime. This is helping our customers to build their workflows and create custom behavior. And those screen models consist of screen elements. For those, we have UI templates which describe the look and feel of those controls. It's a special language providing consistent look and feel all across the products and devices. It's based on SVG, but with some extensions in order to communicate with the rest of the system. And do not forget, this is necessary because we have different sizes, we have different products. All those we want to serve in a consistent way. And those UI elements are mapped into Qt rendering primitives. Data models, proxying information between the backend and the front end. And at the end, we build a scene graph out of that structure, which helps us optimize and control the rendering process. We have to pay attention to two things there. One is the time it takes to load those screens, providing a fluid interaction, and then the part where we just update the screens and handle all those changes coming from the backend. So if you look at that, we have a lot of interfaces and modules, a quite complex system, maybe even too complex. I guess many of you already was able to put together the picture. In the initial iterations of our products, we faced quite some challenges with the rendering performance and the development efficiency. Ever since, we implemented a lot of improvements, making sure that we enhance these areas. But going back in time a little bit, on the last Word Summit, the Qt software creation flow was presented with a lot of tools, helpers, tricks, and guides how to improve the performance of your Qt application. And that made me thinking, do you know what? I realized that we are barely able to use those tools simply because we have way too many abstractions and complex structures in our setup. So we reached out to the Qt professional services for help. And the guys were sitting together with our development, analyzing the code, reviewing specific parts, and also making those tools work in our special environment. I have to say, we received really professional support from the team. And with that, we were able to identify the first set of findings to improve the product. So we organized a lot of knowledge sharing meetings within the teams or with the teams. And obviously, as the tools started working in our environment, it was easy to extend this kind of knowledge to the rest of the software stack and for the complete product. And following this path, keeping in mind, if you aim for excellence, you are never finished. We ever since iterated through those steps and implemented a lot of improvements. But let's talk about some of those aspects. It's not just the code alone that needs to be changed in such situations. Usually there is much more behind. And the first approach is the organization, or the first stage is the organization. The teams must be very well aligned. They must have the same goal, they must have the same understanding of performance in order to build something great. They have to get access to best practices. They need working tools in that ecosystem to fine-tune the applications. And the culture in those teams must reflect our embedded DNA. Otherwise, you are unable to master all those layers, modules, and interfaces that we have in our product. You really have to flip every bit to get an industrial-grade, high-performing device at the end. So we moved the teams around and we made sure that in every team we have the right competency bundled, making them able to do vertical cross-cutting changes, going deep on the topics. The next one is the architecture. Obviously, you need clear and simple architecture. Something that is low to no effort to implement as a design for the teams. And you have to focus on the customer value and definitely not on complex structures. So all the architectural trade-offs and decisions must be very well checked and you need a design all the time. You need a design and proof behind those designs to achieve this. Then moving to the code. The code must be also clean and well structured. And I believe that governance is a key there. The code must be governed by the architects, by the lead developers. And with that, we are again back by the organization and the architecture, and especially the people behind. Those highly skilled professionals must be proud of their work. They must be proud of the code that they produce every day or govern every day. No unnecessary trade-offs, no workarounds. And then the last step is the testing part. So in our organization, every developer needs to have a panel sitting on the desk so that they are able to test with the right hardware in the real environment and using real customer projects. They have to test the jobs to be done by our customers, making sure that whatever they develop really fits and works well. They have to feel the pain, so to say. And we even introduced new test cases recently based on real customer projects, checking how they implemented their workflows and not relying on the best practices coming from our in-house development. And let me be honest, all that I explained to you is no-brainer. These are straightforward things. But in an organization where you have several hundred developers working on a product, not even one product, but many products and product families, where there are regulatory changes all the time, they develop different features every day. It is very easy to forget those basics. And therefore, we have to bring those impulses into the teams every day. We have to re-enable those guys and make sure that the teams are engaged in what they do. And all those really helped. We were able to return to our embedded DNA, and we are able to deliver industrial-grade products every day. So first of all, thank you for the teams helping me on this journey, and thank you also for your attention today.